Hello, you are welcome to my class today. My name is Dr. Kingsley. In my class today, I'll be taking you on preparation of alkynes. Preparation of alkynes. Now, I'll give you 4 methods by which alkynes can be prepared. Number one of those method. Number one is action of cold water on calcium carbide. Action of cold water on calcium carbide. Now calcium carbide is CaC2. We are adding cold water to it, and it's going to give us methane CH triple bond CH. That is ethyne. It's going to give us ethyne. So anytime we add cold water on calcium carbide, we are getting ethyne, plus calcium hydroxide. There are two important things we need to note from this preparation. Number one is that the reaction is highly exothermic. And because it is exothermic, enormous amount of heat is usually liberated. That is why if we are taking this reaction using a glass flask, we need to add sand. Sand is normally added to the flask, in order to absorb the heat that is liberated, to prevent the flask from breaking. Now another thing we need to note here is that the calcium carbide most times can contain impurities, something like phosphorus impurities, sulfur, nitrogen, or carbon impurity. So if it contains phosphorus impurity, if the calcium carbide contains phosphorus impurity, the product, one of the products will be phosphine. That is phosphine, pH3. So this is a phosphorus impurity will give us phosphine. That is a pH3 as part of the product. If this calcium carbide contains sulfur impurity, we'll be getting hydrogen sulfide. We'll be getting hydrogen sulfide, H2S, as part of the product. So it's possible we have H2S as part of this product. Then if it contains the calcium carbide contains nitrogen impurity, we'll be having ammonia as part of the product. We'll be having ammonia as part of the product. So it's also possible that we'll have plus NH3 as part of the product. Then if it contains carbon impurities, we might be having carbon 4 oxide as part of the product. So it's possible we have carbon 4 oxide as part of this product. Now we need pure methane. Ethyne, sorry. We need pure ethyne. But here there are some impurities, depending on the impurities in the calcium carbide. So it's good we remove these impurities in order to have our ethyne to be more pure. Now ethyne that have impurity of phosphine normally have garlic smell, because phosphine smells like garlic. So how do we remove these impurities? So I'm going to give you a tip on how you are going to remove the impurities. Now if you have phosphine impurity and the hydrogen sulfide impurity, we can remove these two impurities using CuSO4. That is a copper 2 tetraoxosulfate 6. We can use it to remove phosphine impurity and hydrogen sulfide impurity. Then the hydrogen sulfide, the phosphine, can also be removed by oxidation. You can oxidize the phosphine using iodine and the KMnO4. Two of them are oxidizing agents. Mild KMnO4 can do. So we can use it to remove the phosphine. Then the carbon 4 oxide, which is CO2, Okay, it can be absorbed using KOH, that is a potassium hydroxide. So depending on the impurity that you have, you can use any of these what reagents, okay, to remove them. That is number one on the preparation of alkynes. Then number two, how do we prepare alkynes? Number two, we can prepare alkynes by double dehydrohalogenation of alkyl halides. Alkyl halides are haloalkanes. Okay, haloalkanes, we can do double the hydrohalogenation. What it simply means is that we remove two molecules of what? Hydrogen halide. Okay, hydrogen halide from, okay, from alkyl halide. What I mean by this is, if we have CH, H, then H, then we have a CH, okay, okay, let's say we have Cl and the Cl, then we have what? H. This is what? Alkyl halide. Okay, we want to remove what? We want to remove what? Okay, molecules of what? Of hydrogen halide. We remove hydrogen and what? And the halogen, chlorine in this case. When we remove hydrogen and chlorine, double bond will be created. Then if we remove another hydrogen and chlorine, another double bond will be created, thereby converting alkyl halide, okay, to alkyne. Now, this reaction will require potassium hydroxide in ethanol, C2H5OH. It will require, okay, potassium hydroxide, that is what? A base, and in ethanol. Now, if we have this, what we will have is, let's say from here, okay, hydrogen and halogen goes off. What we will now have remaining or left is CH, we have a H, okay, then we have double bond, then we have what? C, we have H, and Cl, okay. The name of this compound, which is alkyl halide, is actually 1,1-dibromo, 1,1-dibromo, okay, ethane. And when we remove chlorine and hydrogen, okay, double bond is created. So what we have here is what? One, okay, what we have here is one chloro, okay, ethane, one chloroethane. Now, it's possible again for us to go further in this reaction to remove what? Hydrogen and another chlorine. So if we do that, what we'll be having, okay, I want to continue this reaction. I want to continue the reaction by removing, okay, hydrogen and halogen. So what we'll have is a H and a H. So we'll have a CH and a Cl, okay, plus another molecule of KOH in ethanol, okay. So this and this will now go. Remember, this and this went to give us this. Then when this and this is going, we are going to have what? Of course, we have plus KCl plus H2O. They are byproducts. That is why I was not putting it earlier. Remember, when this one goes, okay, it goes with what? OH to give you water. Then the Cl will go with what? Potassium to give you KCl. So from here, what we'll have is these two groups going off. We'll have C triple bond now, CH plus KCl, okay, plus H2O. So that is what? That is ethyne. Now we can go straight, okay, if we put 2 molecules of KOH, okay, at the same time. What I mean by this is, if we have the compound we have Cl and Cl, then H. If we have this compound and we put what? 2 molecules of KOH in ethanol, okay, what we will have straight away should be what? Methane. Methane plus 2 molecules of KCl plus what? 2 H2O. That is the overall reaction. Okay. Now, having gotten this, remember this compound we use, 1,1-dichloroethane, is actually what? Geminal. Geminal dihalide. Geminal dihalide. We can, if we like, still use what? Vicinal dihalide. We can use vicinal dihalide. Let's say we have a HCH, okay, then H, okay, let's say we have a Br here, then C, we have Br, okay, H and what? And H, okay. This is what? This is a vicinal. Vicinal, I hope you can see the board. Vicinal dihalide. Vicinal dihalide. Okay, vicinal dihalide. So we can use a 2 KOH in ethanol. If you don't want to use KOH, you can use sodium hydroxide, which NaOH in ethanol. That can also go. So what we now have is what? We'll have a HC triple bond CH, which is a ethyne, okay, plus 2, okay, KBr plus 2 H2O. So that is it. So anytime we do double dehydrohalogenation of alkyl halide, we get what? We get alkynes. All right. That is the second method by which alkynes can be prepared. Remember that the mechanism of the reaction, we can give the mechanism of the reaction. If we have CH, okay, H, you have a H, then you have a CH, okay, C, Br, and then Br, okay, then you have H. Then we are reacting with, of course, KOH, okay, in ethanol, C2H5, OH, ethanol. So what actually happens is what? This hydrogen leaves, the bond comes here. The bond of this hydrogen, the bond comes here, okay, because what is picking it is what? OH. OH picks what? This. To give you what? To give you H2O, okay? OH picks this, that is OH picks hydrogen to give you water, okay? The bond here, which is bromine, the bond leaves. The bond leaves. That bond that leaves, okay, we pick what? We pick K, okay? This is minus, this is what? Plus, okay? Remember, this is minus. So this one goes to pick what? To pick a potassium, okay? When it picks potassium, it will give you plus, okay, plus KBr, okay? And what is now left here should be CH. You have a double bond CH, okay? You have a H and of course the Br, okay? That is it. Now the reaction can go again. The reaction can go again if you add another molecule of KOH, okay, in ethanol, what will happen is this bond will go here. The bond here will go here to make it what? To make it triple bond. Why this bond will leave? Okay, remember the OH here, OH will go to pick what? To pick this hydrogen. This OH now goes to pick this hydrogen. When OH picks hydrogen, it will give you H2O. Okay, H2O. Then the potassium here will go to pick what? Bromine. The potassium to give you K, okay, Br. Okay, why? What is now left is HC, triple bond C and what? H, which is what? Ethyne. So that is the mechanism of that reaction. Hydrogen leaving to create a bond, bromine also leaving, okay, to pick the metallic what? Ion. Now, that is number 2 on the preparation of alkynes. Number 3, we can prepare alkynes. So number 3 is, okay, reaction between terminal alkynes and alkyl halide. So another way we can prepare alkyne is by the reaction between, okay, terminal alkynes and alkyl halide to give us an alkyne of longer carbon. Okay, now if we have a RC triple bond, okay, CH, this is what? A terminal alkyne, because the carbon double bond is at number 1. So this is a terminal alkyne. Now these terminal alkynes, they have what? Hydrogen that is slightly acidic. Okay, this hydrogen is slightly what? Acidic. Because it is slightly acidic, okay, it can be reacted or can be removed with what? A very strong what? Base, such as sodium amine. Okay, this is sodium amine, is a strong base. It can remove what? The slightly acidic what? Hydrogen of terminal alkynes. Now if this reaction goes on, what we'll have is R, okay, C, triple bond, okay, C. Then you have what? Na plus. So this carbon atom is partially negative. Okay, then what will generate is ammonia, NH3. Remember, ammonia is a gas, and because it's a gas, it is removed by, okay, on its own by bubbling out. Okay, then this what? Compound that we generated, which is what? Which is acetylide ion. This is acetylide ion, which is nucleophilic acetylide ion. Okay, this nucleophilic acetylide ion can now, okay, react with an alkyl halide. Okay, an alkyl halide, primary alkyl halide in this case, primary alkyl halide. So R prime, okay, X, R prime X. When this happens, we'll have RC, okay, we'll have triple bond C. Then this goes to pick what? Sodium goes to pick the halide, while the alkyl group is okay, is attached. So that what we'll have is what? R, okay, plus NEX. So you can see that what? That we are now having what? An alkyne of what? Longer carbon atom. When we react what? Terminal alkynes with okay, an alkyl halide. Now I want to take a particular example with an alkyne. Okay, let me do this with propane. Now if we are reacting with propane, we are having CH3, C triple bond CH. Okay, this is propine reacting with NH2. Okay, what we'll have is what? CH3. We'll have a C triple bond. Okay, C. Okay, Na plus NH3, which is a byproduct, the ammonia. It can bubble off, so that when we now react with CH3, okay, CH2, then X, what are we getting? Now this is plus and this is minus. So now this is plus, this is minus. What we will now have is CH3, okay, C triple bond C. Then we'll have CH2, CH2, then CH3 plus. We can use bromine. Okay, we can use bromine plus NaBr. Okay, that is the product we'll be having. We started with propine, and what we are now having is 1, 2, 3, 4, 5. 1, 2, that is pent 2-ine, which is of longer carbon atom than the terminal alkyne that we began with. Now, what of when we use 2 carbon atom alkyne, that is CH, triple bond CH. Okay, this is a ethyne. When we combine, we react ethyne with a sodium amine. What we will have is a CH triple bond, okay, CNA, okay, plus NH3. Okay, then when we react with CH3, CH2, maybe Cl in this case, okay, what we'll be having will be CH3. Okay, sorry, we have CH, then triple bond, then we have C, then CH2, CH3 plus Na, okay, NaCl. Now, if you look at this, you can see that what? Because we began with ethyne and we have lengthened the carbon atom, we are still having what? This product to the terminal again, because if we are to number this this alkyne, this is the nearest to the triple bond, so this becomes number 1, this is number 2. You see that the product is still what? Is still a terminal alkyne. So we can do what again? We can react what? With sodium amine again to continue the reaction. So this product, we can combine it with NH2. Okay, when we do this, this is the side that will be attacked. So we'll be having CH3, CH2. Okay, this is what? C triple bond. Okay, this is what? C. Then we'll have what? Na. Okay, Na plus, then plus what? Plus ammonia, which is NH3. Then this compound now, we can now react it with what? With a CH3, CH2. Okay, we have okay, CH3, Cl. Okay, what do we get when we react this? We will now be having, okay, these 2 groups attacking this side. So what we'll have is a CH3, CH2. Okay, then CH3, okay, CH what? 2, or CH3, we have a CH2, then we have what? C triple bond, then we'll continue with our C, then CH2, okay, CH what? 3. So you look at the compound, we find out that what? We have now gotten what? We have now gotten, okay, an alkyne that is not terminal. So our reaction can actually what? Can actually stop at this stage. All right, that is number 3. Then number 4, how we can prepare alkynes. Number 4, can prepare alkynes by, okay, halogenation of alkenes followed by double dehydrohalogenation. We have done the double dehydrohalogenation before. We have done double dehydrohalogenation. So when we have CH2 double bond CH2, so we want to what? We want to first of all what? Halogenate it. Halogenation. We are halogenating it with what? Bromine. So that what we'll have is CH2Br, then we'll have CH2Br. So when you look at these two hydrogens can be written as H and H here. These two hydrogen here can be written as H and what? And H here. So we have now seen what? A vicinal dihalide. This is vicinal. Okay? Vicinal dihalide. Okay? Then we can now do double dehydrohalogenation. So if we take 2NaOH in what? Ethanol. In ethanol. What we'll have will now be, okay, CH triple bond CH, which is what? Which is ethyne. So these are the 4 methods by which alkynes can be prepared. Please subscribe to my channel if you have gotten something from this class. Okay, like and share. All right, I will be continuing the class, okay, with reactions of alkynes. Remember, this class will help you if you are preparing for exams such as AP, GCSE, okay, SAT, WAEC, NECO, JAMB, okay, UTME. If you are preparing for JUPEB, first year students, this class will be very important. So do subscribe to my videos to make it go further. Thank you very much.